We're going to look at learning objective A, and I'm going to show you how to write zeros of polynomials as factors. In the previous section in chapter 7, we talked about what zeros are. And remember, another name for the zeros are just the x-intercepts. Another word you might hear is roots, or answers, or solutions. They all mean the same thing. And one way you can find them is to take the equation of the polynomial, which is right here, and you can factor it. And I'm going to tell you, if you factor this completely, here's what it's going to look like. We're going to have 2 times x plus 5, x minus 1, and x minus 3. And this one involves a little bit higher level of a factoring technique we don't need to worry about. But what I want you to get from here is, can I identify the zeros? Remember, to find the zeros, we would take the equation and set it equal to 0. Then all you're going to do is you're going to take the factors. You're going to take each of these 3 factors and set them equal to 0 and solve. So x plus 5 equal to 0, x minus 1 equals 0, and x minus 3 equal to 0. If you solve that, you're going to get ones at -5. Another one here is going to be at 1. And this last one is going to be at 3. Let's make the last connection here. Remember, we said another name for the zeros are the x-intercepts. Well, if you look at this graph right here, I put this into the graphing calculator, and here's what it looks like. Notice where the x-intercepts happen. They happen at the -5, 1, and 3. So what we can get from here is that the x-intercepts of a graph are the same as the zeros. The zeros from an equation come from their factors, and the factors come from the standard format of the polynomial. Now, some key definitions relating to factors. This theorem here says if we have a particular polynomial and we find a factor of that polynomial, then if you take the opposite of this value, so if this was, for example, let's say the factor was x minus 2. So if we took the opposite of -2, but we took +2, if we took +2 and put it back into the original polynomial, what would happen is it would have to equal the number 0. That's what it means to be a zero. Okay. Other important theorems about factors and zeros. If c is a zero of the function, then what we can know is that x minus c is considered a factor of that function. We also know if this c value is an x-intercept or a solution, then if we put it into the function, it'll equal 0. We also know that c is considered to be called the x-intercept of the graph. Point 4 here says c is actually called a zero of the function. And point 5 says here, the remainder, when we take p of x and divide it by x minus c, or if we divide it by that factor, the remainder will come back to be 0. Well, let's look at this last example. We have here a 4th degree polynomial. And what they want us to do is see if we can identify the zeros of the function, and then we're going to write them in factored format. So notice here again we have the 4 x-intercepts that we can see, and notice the x-intercept of -2, the y is 0. All 4 of them have y values of 0. Therefore, they are the x-intercepts, or the zeros. So what we can do is we can take the 4 x-intercepts and write them as factors. So we see the standard format up here, and we can easily write this in factored format now that we have the zeros. So if we take the 0 of -2, that becomes p of x equals x plus 2. The 0, which is at 0, I'm just going to write as x. The 0 at +2 is x minus 2. And the 0 at +6 is x minus 6. Now, I do want to show you that this video you actually can factor by grouping. So let's take a look. If we group these 2 and these 2 together, see what we can pull out. Of these first 2, it looks like we can pull out an x cubed. So if I do x cubed out, I'm left with an x minus 6. Now, from this group, we want to see if we can pull out enough so we're left with an x minus 6 in here. And if we pull out an x from both and a -4, we should do it. So a -4 and an x are being pulled out. So then I am left with x minus 6. Okay, we were successful in that we do have a group that matches, so I'm going to pull this out of my group and be left with x minus 6, and then we're going to have x cubed minus 4x. Now, is there anything else we can yank out of here? It looks like what we could do is from here we can actually pull a single x out. So let's do that, and we'll just do x minus 6, pull out that single x, and then we're left with an x squared minus 4. Now be careful, this here can be factored further. We can factor this into x plus 2 and x minus 2. So the final answer when we factor fully would be x minus 6 times x minus 2 times x plus 2, which shows us that we actually can factor this using algebra quite nicely, but we can back it up if we were to look at it on the zeros of the graph.